All right, so we just finished the first two problems. We're going to part 2 of section 8-2. Section 8-2 on page 5. Section 8-2, we'll call this part 2. All right, the next one, simplify this one. Simplify it, try to get it down to a really simple type of trig function at the very end of this thing. I got nothing but cotangents and cosecants, but what you should notice more than anything is that it follows the pattern of a plus b times a minus b. These two parentheses look almost the same, except one's a plus in between, one's a minus in between. And what happens is when you multiply two parentheses like that, two binomials, you get what's known as a difference of squares pattern, very popular. So you're going to take cotangent x times both of these. All right, so cotangent x times both. And I'm going to show more work than is necessary. The middle parts are going to cancel out. I'm going to show that just so that if nobody is following what I'm saying, then they'll see why I'm going to cancel them out. But usually you don't even write the middle part out. Cotangent times cotangent, cotangent squared x. Cotangent x times minus cosecant x would be a negative, because one positive times a negative, and it would be cotangent x, and a little dot, cosecant x, one times the other. Okay. Then it's going to be cosecant times cotangent, but it's positives. Cosecant x times cotangent x. And then it's going to be a negative because it's a positive times a negative, and that's cosecant squared x, cosecant times cosecant. Now, what's going to happen is the middle parts cancel out. This is cotangent times cosecant. This is cosecant times cotangent. They're the same, but one's a minus 1 in front, and the other one's a plus 1 in front. They cancel each other out, even though they look kind of ugly. You get cotangent squared x minus cosecant squared x. Anytime you got stuff that is squared and a plus and minus in between especially, you're going to look for Pythagorean identities. And there is one that deals with cosecant and cotangent. So if I were to subtract cotangent to the other side, you could write this as cosecant squared minus cotangent squared equals 1. So cosecant squared, but it has to be cosecant squared minus cotangent squared, and this is the other way around. So we just learned what to do with that. You're going to take a negative 1 out, and it'll change what the signs are for each one. It'll make this a negative cotangent squared x, and this a positive cosecant squared x. And what that does is it lines up what I'm looking for. I'm trying to get these both on the screen at the same time. I want it to be cosecant squared minus cotangent squared, not the other way around. Let's see if I can focus that a little better. Yeah, there we go. If I subtract cotangent squared, the cotangent needs to be negative, not the other way around. Then it can equal 1. So now I did that. It's a negative cotangent. Like, you can write this part first if that makes you feel any better. Cosecant squared x minus cotangent squared x. All right, this parentheses is the same as this parentheses, but the parentheses comes out to equal 1. So it's a negative 1 times a positive 1, and all this mess comes out to equal negative 1. Negative 1 is the final answer of this problem. All right, let's move on. One more problem. I think there's only one more. Yep. One more problem. Well, basically, it's the exact same type of problem. It's going to follow difference of squares pattern. If you have a plus b and you multiply it by a minus b, all right, you're going to get a squared minus b squared. And so you don't have to write all the stuff that I did on the other side. If you can recognize it, hey, this parentheses matches this one, except this is a minus in between and that's a plus in between. Okay, one's a minus, one's a plus. Then I can just say, hey, the middle part's going to cancel out. It's going to be 3 times 3 is 9 minus, and then this is the 3 times a 3 here, so it's 9 sine squared x. That's kind of odd. We haven't had something like that, and it's definitely not the Pythagorean identities because, it's got that 9 in there. That 9 kind of screws it up. So what do we do? So they both have a 9. What you can do is take a 9 out. factor that out. And then you can create the identity. There, that's going to match. 1 minus sine squared x matches the trig identity here. If I subtract sine squared to the other side, 1 minus sine, here it is right here, 1 minus sine squared equals cosine squared. So this is going to equal a 9 times cosine squared. And that's actually it. That's as simplified as we can make it. 9 cosine squared x. 9 cosine squared x. Boy, it feels like this is a really short video. I almost could have squeezed it all onto one. Maybe I can come up with one more. It's hard to make these up without making a complete mess. I think a fraction one would be a nice one to show. If I could think of a fraction problem to use. Let's see if I got some extra problems somewhere in the back maybe. Sometimes when I do these videos, I put some extra problems in there for you. I'm not seeing any. That's 8-5, 8-4. And you're just listening to me sit here and think about it way too long. That is the end of the notes. I'm thinking for class tomorrow, I may need to come up with another fraction example. I just don't have one in front of me, and unfortunately, I can't spend the time looking it up right now. But that seems a little bit short. I feel like we need another example of the fraction one that was in the beginning. Really, that was the toughest one, the one in the beginning of our notes today. All right, I'm going to wrap it up right here. If you have any questions, please let me know.